Welcome everyone to Numerical Solution to See Problems. Let us discuss our Module 1 entitled Determinants and Linear Systems. The activities involved are reading, comprehension, solving problems, and hands-on exercises. With our introduction, the determinants are useful tools in determining the solution of simultaneous equations and also useful in calculating inverse of a matrix. Our learning outcomes. At the end of this topic, you are expected to know the expansion of determinant, true minors and cofactors, recognize the properties of determinant, use properties of determinant in solving complex forms or complex problems, and apply determinants in solving simultaneous equations. So let us start with determinant as element. Consider the following three equations having three unknowns, such as x, y, and z. So usually, nakikita natin lagi ang simultaneous equation in this format. So name it equation 1, 2, and 3 respectively. So from 1, 2, and 3, by cross multiplication, we can get the fractional format of equation by equating them to their constant, or specifically getting the value of x, y, and z through equating to their element and multiply by their constant. And substituting the value of x, y, and z in equation 1, we can get the so-called element. So ito na siya sa kanyang expanded format, or ito rin siya sa, we call it equation 4. So from 1, 2, and 3, by suppressing x, y, and z, the remaining can be written and the determinant as, ito na siya, sa ganitong square format. So this determinant is of third order. So yung equation 4 and 5 ay isa lang siya. Kaya pwede natin siya na i-equate. Kasi pag sinabing equation, yung left side at saka ang right side ay isa lang yung value niya. So yung tawag dito sa ating nasa left ay left side equation, or left hand side, at ito naman ang right hand side. So by simplifying, ito na siya sa kanyang mga may minor. So ito yung element A1, B1, and C1. Let us recognize the minor. The minor of an element is defined as determinant obtained by deleting the row and column containing the element. Thus, the minors of A sub 1, B sub 1, and C sub 1 are respectively, ito na daw siya. Ito yung for C sub 1, A sub 1, B sub 1, and C sub 1. So, paano nakuha yon? So, let us apply yung sinabi na i-cancel natin or delete the row, the column, and row ng kung saan yung location nun. So, for A sub 1, kung ito yung kanyang location, itong corner na to, ito yung column, ito yung row. Kaya ito yung row 1, row 2, row 3, column 1, column 2, column 3. Ito yung location ng A sub 1. Row 1, column 1. So, kapag kinross out natin yan, ang matitira ay B2, B3, C2, C3. So, ito yon. Ito yon. Then, kapag nandun na tayo sa B1, cross out natin to, saka yung column 2, ang matitira ay A2, A3, C2, C3. Sa C1 naman, cross out itong third column and first row. So, ang matitira ay A2, A3, B2, B3. Ayan. Kaya, ito siya, respectively. So, by cofactor, ito yung formula niya. Negative 1 raised to R plus C. Multiply by minor, where R is the number of rows or of the element and C is the number of columns of the element. The factor of any element of 8th row and jth columns is negative 1 raised to I plus j minor, multiply by minor. So, kaya ang cofactor ng A1 ay sundan natin yung kanyang formula, negative 1 quantity raised to 1 plus 1. Kasi yung kanyang location ay row 1 and column 1. So, 1 and 1 multiply by ng kanyang minor. Then, kung nasa B2 naman tayo, ito yon B2. Ang location niya ay row 1, column 2. Ang location naman ng C ay row 1, column 3. Kaya siya ay naka-raise sa 1 plus 3. At itong B na nasa column 2 ay 2 plus 1 and multiply by their respective minors. So let us illustrate what have been discussed dito sa example number 1. Write down the minors and cofactors of each element and also evaluate the determinant. So ito yung data niya. So umpisa tayo dito sa left corner sa 1. So kung ito yung 1, cross out ito, cross out ito. So yung walang color, yun yung minor ng element 1. Then proceed doon sa elementary operation. So downward diagonal multiplication is positive and upward diagonal multiplication is negative. Kaya negative 5 multiplied by 2, ito siya. Then minus yung pataas, 6 multiplied by 5. So that is negative 10 minus 30. That is negative, positive 40. So kunin natin yung cofactor dahil may 40 na tayo na minor. So negative 1 doon sa element 1. Negative 1 raised to column 1, row 1. Kaya ito ay negative 1 raised to 2 multiply by negative 40. That's negative 40. Then proceed tayo sa ikalawang element. Dito tayo, 3, cross out yung row 1 and column 2. Kaya yung walang color, yun ulit ang kanyang minor. Kaya ito ay 4 multiply by 2, going down, positive, going up, minus 3 multiply by 6, that is 8, minus 18, that is negative 10. Then yung cofactor niya, ayun, positive 10. Kasi sinundan lang natin yung kanyang formula. Then, M13, ibig sabihin, element doon sa row 1, location ay column 3. Kaya yun yung negative 2. Then, proceed. Ito yung kanyang minor, yung walang color. Then, proceed to elementary operation. That is 35. Then, yung cofactor, since siya ay negative, ng negative 2, so negative 1 raised to row 1, column 3. That is 4. So, kaya ito yung magiging positive 1 multiplied by 35. That is 35. Then, lahat ng to, ulit-ulit lang din para masanay kayo. Yun, then, proceed tayo dun sa evaluation ng determinant niya. Yung determinant, ito yung formula. So, every element multiply by its cofactor na nasolve na natin kanina. So, ang ating element ay 1. Kung dito tayo sa row 1, 3, and negative 2. Kaya yung nakuha natin kanina na cofactor ng element 1 ay negative 40. Tapos, dun sa 3 ay positive 10. Dun sa negative 2 ay 35. Kaya, ano natin to? That is negative 80. So, another fairly convenient method for evaluating third-order determinant is by repeating the first two columns of the determinant to the right of it, and then taking the sum of the products along diagonals parallel to the main diagonal minus the products along the diagonals that run up from left to right. So, ito yun, no? Kaya pareho lang yung kanyang sagot. Hindi ko alam kung pwede yan sa 4x4. Tatry natin. So, sundan lang yung kanyang elementary operation. Makuha natin yung negative 80. Then, example number 2, evaluate the determinants. So, ito yung data. So, dun sa row 2, dalawa yung 0. So, dito, suggest sa atin, proceed agad tayo dun sa row 2. Kasi yung dalawang 0, isa na lang yung kukompute natin. Kasi any number, multiply by 0 is 0. So, dito, dahil tayo ay nasa second column, mag-uumpisa tayo sa negative then positive, then negative ulit. Dahil nasa second row na tayo. Then 0, ito yon second row, cross out yung column 1. Kaya matitira ay negative 1 and 5, negative 2 and 0. Then pagdating dito sa ikalawa, that is eliminant or minor 22. Kasi row 2, column 2. That is, ang matitira sa kanya ay 3 and 3, negative 2 and 0. Then, doon tayo sa negative 1. Ang matitira ay 3 and 3, negative 1 and 5. Then, itong dalawang ito, na quantity ay 0. Then, negative multiply by negative, that is positive. Then, 3 multiply by negative 5, that is negative 15. Ito yun. Then, minus going up, negative 1 multiply by 3, that's negative 3. So, negative 15 plus 3 is negative 12 multiplied by 1, that is negative 12. So, yan. So, kailan ba gagamitin? Bakit dun sa nauna kapag row 1 ay nag-umpisa sa positive? Positive, negative. So, ito yung explanation niya. So, instead na using yung cofactor na lagi natin gagamitin do kasi baka magkalituhan dun sa kung saan location. So, the cofactor of an element is simply its sign, minor. The sign being positive or negative according to the law of cofactor, that is, quantity, negative 1 raised to I plus j multiplied by minor. Therefore, the sign may also be obtained from a checkerboard arrangement of positive and negative signs. One starts with positive with the upper corner. Kaya ito yun. Sa 3 by 3, sundan lang natin ito. Basta laging yung first row ay yung upper left corner ay positive, then alternating. So, hindi malilito. Ito yung 4 by 4 matrix. Number 3. So, ito, kayang-kaya nyo na itong reviewin. The rest nyan ay kayo na ang mag-review. Yan, then number 4. Kasi dito, referring to second row. Tapos, referring to third row naman. Then, the rest, solving problem. Ito yung template number 1 natin. Kasi meron tayong laboratory na 3 hours within a week. Yun ang gagawin nyo during the laboratory hours. Pagsasagot nito. Ng mga solving problems. Then, proceed tayo sa properties ng determinants. So, property number 1, the value of determinant remains unaltered if the rows are interchanged into columns for the columns into rows. So, kapag in-interchange siya, pareho lang din ang kanyang value. So, ito yung proof niya by interchanging. Yan. Kaya yung proper 2, if 2 rows or 2 columns of a determinant are interchanged, the sign of the value of the determinant changes. So, halimbawa daw, itong row 3, saka yung row 1 ay pagpalitin natin. Then, pag nag-proceed ka sa computation ng original, kung ano man yung sign ng original, tapos pinagpalit mo, iba na. Ayun na, katulad nito. Nung ma-prove niya, yung a sub 1 is equivalent to negative a sub 1 napalitan. So, yun yung isang property niya. Then, the property number 3, if 2 rows or columns of a determinant are identical, the value of the determinant is 0. Parang ito, yung row 1 at saka yung row 2 ay identical. So, pag nagkita tayo ng ganito, ang value agad ng determinant na yan ay 0. Property number 4, if the elements of any row or column of a determinant be each multiplied by the same number, the determinant is multiplied by that number. So, kung ito man, halimbawa, i-multiply natin sa m, or yung row ay i-multiply natin sa L. So, katulad nitong example, yung row 1, minultiply lahat sa K. So, yung buong determinant na yan ay equivalent nung kapag pinactor out natin yan dun sa labas ng absolute sign, that is K. Ito, ayun. Lahat ng yon ay pwedeng i-multiply dun. Then, number 5 property, the value of the determinant remains unaltered if to the elements of the row or column be added by any constant multiple of the corresponding elements of any other row or column respectively. So, ito yung kanyang demonstration. So, dito, kapag minultiply daw natin ito, yung any row at tapos ini-add ulit natin, ayun ang kalalabasan niya. Ito. Nagkakaroon ng identical, so 0 pa rin yun, so remain, ito pa rin siya. So, itong properties na to, useful siya pagdating ng mga complex simultaneous equation. Kaya doon masusukat yung husay natin sa analysis. So, pagdating dito, meron ulit tayong solving problem dito that is short template number 2. Ayan, lipat tayo ng factor theorem. So, ito yung susundan lang natin sa factor theorem. If each element of matrix A is a polynomial, and X and F, absolute A, o yung determinant natin, vanishes for X equals A, then X minus A is a factor. So, lilinawin natin yan kapag diniscuss natin yung mga example. So, this theorem is very much useful when we have to obtain the value of the determinant in factors form. So, yung kalawang rules, if we substitute B for A and the determinant, the absolute A, any two of its rows or columns become identical, then absolute A is equal 0. So, yun yung application ng property kanina, na kapag merong column na identical or rows na identical, ang value ng determinant ay 0. Number 3, rules, if rows or columns are identical and determinant of order m, whether your n ay greater than or equal r or rows, when we put x minus a, then x minus a is a factor of the determinant. Then rule number 4, a square matrix or its determinant is said to be cyclic. Symmetric form if each row is obtained from the first row by changing the variable cyclically. So rules number 5, if the determinant is cyclic symmetric form in Fm is the difference between the degree of the product of the factors obtained by substitution and the degree of the product of the leading diagonal elements and F. So, ito na, dito na tayo mamimili. Kung ang kalalabasan daw nung M ay 0, then the required factor is a constant K. Ngunit, kung ang M ay equivalent ng 1, then the required factor ay ito, na quantity na to. K multiply by quantity A plus B plus C close quantity. Ngunit, kung ang M ay equivalent ng 2, ito naman yung kanyang factor. So, let us discuss one example. Ito. Example 9 show that ito daw na determinant na to ay equivalent nung ito. Tawag dito ay RHS. Right hand side and left hand side ay equal. So, let itong determinant na to ay sa absolute A. So, ito, just copy the all value. Then, let x is equals y. Ito, kinuha muna natin to. Then, lahat na makikita natin na x, papalitan natin ng y. Kaya dito, yung row 1, column 1, ito, column 1, at saka column 2 ay identical. Therefore, kung yun ang situation, ito ay 0. So, sabi doon sa explanation kanina, kapag ganun ang mangyayari, so therefore, itong x minus y ay factor ng determinant na to. So, the degree of the product of the factors x minus y, y minus z, and z minus x is 3. Kasi dito, kung i-represent naman ulit natin yung y is equal z, magkakaroon ulit siya ng identical na column. At kung i-represent naman natin ang z is equals to x, magkakaroon ulit ng identical na column. Therefore, sa mga situation na yon o sa mga condition na yon, laging magsisiro, na mababanish yung determinant. So therefore, kapag ganun ang nangyayari, itong lahat ng to ay factor ng determinant na to. Kaya dito, so yung diagonal na to, originally, itong diagonal na to, 1 multiplied by y multiplied by c squared. Ito. So pag pinag-multiply mo yan at inad mo yung kanilang exponent, that is 2 plus exponent ng y ay 1, that is 3. Ayun, kaya ang degree daw nun ay 3. Ito naman sa expansion niya, kapag pinag-add mo yung dalawang product niya sa expansion, halimbawa ay y and z squared or z multiplied by y squared, so z, kunwari yung z ang kanyang exponent ay 1 at ang y ay ang exponent niya ay 3. So therefore, ang sum ng kanilang exponent ay 3 din. Kaya yung m niya ay 3 minus 3. Ayun. Kaya 0. Kaya dun sa number 1 kanina, ito, kapag ang nakuha daw natin na m ay 0, ang kanyang required factor is k. Kaya yun ang kukunin natin. K, ang gagawin natin, ito. M is 0, then the required factor is a constant k. Therefore, the other factor is k. Kaya yun, insert natin dito. Dito, yung k. Ayun. So, ayun. So, kaya kapag in-equate natin yung both side dito sa RHS at saka sa LHS, yung nakuha natin kanina na diagonal ano niya, ito yon. At saka yung factor natin dito, yz squared equals kyz squared. So, ang k, ang kalalabasan niyan ay 1. So, therefore, pag substitute mo siya, mapuprove natin na ito at yung left hand side ng equation at saka yung right hand side ng equation ay equal talaga. Ayun, kaya yung mga factor na yon na x minus y, y minus z, and z minus x is a factor nito. Ayan. Ayan. So, that is proved. So, itong number 10, kayo na lang mag-review nito. Kasi ang i-explain ko ay itong number 11. Kasi itong number 10, ito ay application ng property number 5. Yung kapag minultiply ang isang column, then add to it, nagkakaroon siya ng identical. Ayun, susundan nyo lang. Yun, para matuto naman kayong mag-analyze. Yung example number 12. Ayun, using factor theorem, prove that itong left hand side ay equal dito sa right hand side. So, let us x is equals y. So, dito na din natin kinukuha yun. So, kapag pinalta natin yung x ng y lahat, nagkakaroon ulit siya ng identical row. So, dito, Ang identical ay yung row. Ito, row 1 at saka row 2. So therefore, yung x minus y, so kapag may identical, that is 0. At kapag ganun ang condition, yung x minus y is a factor nitong determinant na to. So the given determinant is in cyclic symmetric form in x, y, and z. Therefore, kapag tinulad ulit natin yung ginawa natin kanina, let's say y is equal z and z is equal x, magkakaroon ulit ng identical column pareho. So, ibig sabihin, 0 ulit yun. So, yung y minus z and z minus x as factor ng determinant. Then, proceed tayo dito ulit sa degree nito. So, itong diagonal, ito, yung principal diagonal, z multiply by y is z cube multiply by y square multiply by 1. So, ang kalalabasan niyan ay y squared, z squared. So, ang total ng kanilang sum ng kanilang exponent ay 5. Ngunit dito, kapag in-expand natin ito, magkakaroon lang siya ng total na 3. Yung exponent ng isa sa kanilang product. Ito, 3. Samantalang ito, 5. Kaya yung m natin ay 5 minus 3 equals 2. So, kapag nangyari yon, na 2 ang nakuha natin, ito yung condition. Ayun. Ito yung magiging factor niya. Factor. So, therefore, the factor is, ito siya. I-represent natin sa, imbis na a, kasi ang variable natin dito ay x, y, and z. So, ito yun. Then, letting x is equals 0 and y is equals 1 and z equals 2. So, ito, any number na mapapadali mo, na makakapag-eliminate ka, may i-apply mo na ngayon yung tinatawag nating minor nito. So, kapag ito, ini-substitute natin sa lahat ng to, ito yung magiging value niya. So, yung column 1, remaining 1, yung x ay 1. So, 1 minus, x is 0. So, ito ay 0. Y ay 1. Ito ay 1. And z ay 2. Kaya ito ay 4. Then, dito, z ay 2 multiply by 2, 4 multiply by 2 ulit, that is 8. Then, ito ay 1, remain 1. Kaya, proceed sa mga substitution, sundan nyo ito, kasi ito yung ano natin. So, lahat ng makita nyo na in-assign natin na equivalent niya, substitute, then proceed to elementary operation. So, magka-come out tayo sa equation 1 natin na yung 5k plus 2l is equals 2. Then, dahil dalawa yung ano natin, k and l, another trial, x is equals 0. Then, yung y ay equate natin, equivalent natin sa negative 1 at yung z ay 1. Ayun, upang mapabilis naman yung ano. Kaya, same ulit, ito ulit yung ating eliminant, yung corner, kaya ito ulit ang matitira. Ito kasing 8 minus 4, ito yung eliminant natin, yung corner. So, pag kinross out ulit natin yung column at saka yung row, ang matitira ay 1 and 4 and 1 and 8. Kaya, going down, 1 multiplied by 8, that is 8. Then, minus, going up, 4 multiplied by 1, that is negative 4. Then, ito, elementary operation. Kaya, ito yon. Then, ito, ganun din. Ito ulit ang ating eliminant dito. Ayun. Kaya, 1 multiplied by 1, that is, ito, 1 minus 1 multiplied by 1, that is negative 1. Ito yon. Then, ito, elementary operation. Galing ulit dito. Ayun. Kaya, yung 2k minus L is equals negative 1. Then, through simultaneous solution, ang makukuha natin ay k is equals 0 and L is equals 1. Kapag itong nakuha natin na value ng k at saka 1, pag sinubstitute natin sa original equation, so ito ulit ang kalalabasan. add ito, dun sa may factor ito. Kung ito ay 0, so lahat ng entity na to ay 0. Ito, yun, 0. So, ito ay 1, so ito ulit ay equivalent ng 1. Kaya ito yung originally na ito at saka ito yung originally na nandito. Kaya ibig sabihin, itong determinant na to at saka yung kanyang right hand side ay equal. So, yan yung cyclic at theorem. Ayun. So, medyo sa online marami naman siya na mga example. You can go there. Then, the remaining solving problems dito. Ito yung ating mga exercises sa inyong laboratory hours. Then, application ng determinants sa area ng triangle. Then, sa area ng triangle, ito yung formula ng determinants sa area ng triangle. Okay. So, by next meeting or gawa ulit ako ng video para ito explain naman. Pero kung makukuha nyo in your own analysis, dahil madali lang naman siya, you can proceed to solving problems. Ayun, ito, solving problems. So, bali ilan na agad ang ating solving problems sa inyong laboratory works. Ayan. So, that's all for now. Thank you for your listening. Next time again.